So, here we go. Alright, today what we're in section 4.2 to 4.3 today. We're moving on. Today we're going to be dealing with the trig functions. So,
is that like cosine, sine?
Yep. So we're going to be dealing with the trigonometric functions. So this is the stuff we're going to be dealing with today. I want to make sure that today we get kind of into the swing of things. The good thing is we talked about trig functions back in geometry days. We talked about in algebra 2 days. So hopefully this will make sense to you that we can cover this and we can kind of see some examples of this today. The big thing is we do need to know the different formula for the trig functions. So I want to make sure that we get to that today. There is 6 main trig functions. So there is 6 trig functions to begin with. And the goal today is to go over those trigonometric functions, to go over the names, how they work, what they are, so you know the differences between them, how to type them in your calculator, use a little bit of technology for these. Some people just don't know how to do that. So hopefully today and tomorrow we'll fill you in. At some point today, I will require that you have a calculator out. Now if you don't have one, I have a couple in the back you'll need to borrow. But if you do have a calculator, I recommend that you have your own out so you know how to use it today. This is a great day to get hands-on with it as we go through things. And I will, when I walk around today with the video camera, I will record what thing you wrote down on paper, and you have to show me on your calculator how you typed it in, and actually hit enter so I can see the numbers.
You're personally recording this?
Yeah, I'm gonna personally walk around. Every single person gets recorded.
Okay, I gotta go back.
So, because I need to make sure everything is videotaped, and I've kind of warned you that is for a project coming up at the end of the month for some teachers. So teachers are watching today's video and tomorrow's. So you've been forewarned. So, all right. It's both pre-calcs. I have to record both. So I recorded this morning and now, and I have to splice the videos together, all 4 from today and tomorrow. So it's kind of a long video, and I have to edit it and all that good stuff. All right, it's a project coming up with the administration. I was picked first because I have the camera. So, all right. For the trig functions, here's the 6 names we have. The 6 main ones: sine, and this is probably the one day that I actually write out the full words: sine, cosine, tangent. So these are the main ones that I want to make sure that we know how to do today, which it's pretty much a refresher because some people usually remember how to do this. Then the other trig functions that we have are cosecant, secant, and cotangent. And I wrote those in a very specific way because they're paired respectively. What I mean by that, these are the 3 main ones. And then these 3 down here are what they call the reciprocal functions, right? Reciprocals. They're actually written in the same order with what they're paired with earlier. And I know that seems a little weird. Every trig function, every main trig function, and its reciprocal, one of the pairs always has the letter C as the first letter. So if like sine is paired with one that starts with the letter C, so cosecant. Cosine starts with the letter C, so it's paired with something that isn't secant. And then tangent is paired with something that starts with the letter C, cotangent. Every pairing has one that starts with the letter C. That's how I always remember it. Does that make sense? One of the terms has the letter C in it for the pairs. Okay. The goal today is to focus on the top 3. That's the goal today. The goal tomorrow is to focus on the bottom 3. How to type in your calculator, how to figure out, how to find solutions for them. Do we feel comfortable with it? Okay, does that make sense?
Yes.
Okay, so now let's walk through this. So the big thing about the main 3, because that's what we're focused on today, is this little acronym. Sohcahtoa. You do need to know what Sohcahtoa stands for. It's this little abbreviation that I use to help me remember the formula for the trig functions. Now the trig functions, in the first place, they only deal with right triangles. That's it, right triangles only. Okay, so I'm going to give you the formulas for the first couple. Maybe I'll start with sine and we'll kind of work our way through it. And then I'm going to show you how they relate with the picture, and then we'll do an example of it. Okay, so let's start with the first one. So the capital letters here, these are the trig functions. Okay, that's what the capital letters are. So S, C, and T. Sine, cosine, tangent. The lowercase letters at the back, those are the walls of your right triangle. So we'll label those as we go. But the first one stands for sine. So the abbreviation for sine is SIN. That's the abbreviation we use. Cosine is COS, and tangent we use TAN. Those are the main three. So you'll see those buttons on your calculator as we go through it today. The bottom three that we'll see tomorrow, they have a different abbreviation. They have CSC, SEC, and COT. Now, the problem is, these three are not on your calculator. They're not. They're not the tangent -1 or cosine -1 or sine -1. Question?
What's the point of abbreviating sine if you're just taking off one letter?
Yeah, I agree. They always want to go down to 3, so they just made sure it was consistent for all of them. Because they didn't want to have 4 letters for all of them. It was silly. So, okay, but for the sine function, what this button is on your calculator, when you type in sine, they're expecting you to type an angle after it. So when you hit that little sine button, it's especially on a menu-driven calculator, something like this. That's a menu-driven, you can see exactly what you're typing before you hit enter.
Mine does not pop up. Mine's a parentheses.
Yeah, so it's waiting for an angle after it. Okay, so we'll type in an angle here in a minute. Then the letters after it, the O and H. The O stands for opposite, and H stands for hypotenuse. Now, on a right triangle, hopefully this makes sense to you what those letters are. So for instance, on a right triangle, theta is just one of the angles other than the right angle. So it's got to be one of the acute angles. Remember, on a right triangle, the other 2 angles are acute, they're small. So if I put theta down here, then what we can do is we can label the opposite and hypotenuse to where this angle sits. The opposite is always across the picture. The opposite wall where your angle sits. So if your angle is up here, the opposite wall would be the one on the bottom. Okay, the adjacent wall is the wall next to your angle. Adjacent means next to or touching. And then the hypotenuse is always the biggest wall. The hypotenuse of a right triangle is always the wall that is not touching the right angle. These two are actually called the legs. That's the hypotenuse, it's the biggest wall. Okay? So on this particular trig function, we're using the opposite wall, the wall across from your angle, and we're using the hypotenuse. So what your calculator does for you when you type these in your calculator, like let's say you typed in sine of 30 on your calculator, right? You typed in sine of 30. Well, the idea of what it does is that it's automatically pre-programmed to know what the walls are on a triangle, like the ratios of the walls, and it takes whatever the opposite wall is and divides by the hypotenuse. And so when it automatically does that, it automatically spit out half or 0.5 on your screen. Okay? Now the reason being, and you're probably thinking, Lord, I can draw any triangle. How does it know which one it is? Because it doesn't matter. Whatever the opposite wall is, it's in relationship to the hypotenuse, where the opposite wall is always going to be the 1 unit length. The hypotenuse will always be twice as long, and it will always divide and it will simplify the fraction. Okay? When it simplifies the fraction, it will always turn out to be half. It's just the way that the triangles are set. When you have an angle, the walls are already preset. Like they already know what the ratios of the walls are. And that's why it's useful. That's why having that scientific calculator or graphing calculator, they have them pre-programmed. So now, if the calculator already knows what the walls are supposed to be, you can use that to find what the walls are. You can kind of reverse engineer the problem, which is kind of fun. Okay, so that's what we're doing today. We're going to be looking at like how to use this calculator, how to use this like weird decimal it's giving you to actually find the wall lengths. Okay, but again, when you type in sine of 30, it took the walls and divided them. That's why it's giving you a decimal. It automatically knew what they were supposed to be or what the relationship was. Okay, because that's really what it is. Okay, all right. Does that make sense for sine? Okay, now we'll get to that. I'll explain this whole 30 degrees idea. We'll do an example so you can actually see like how to use it, how to type it in your calculator. Especially because like everyone in this room usually has a different type. Looks like for the most part everyone's got the same style. I'm worried about that little, is that a Casio? Yeah. I think, can you just type in everything and then hit enter? Or does it?
I can't see anything.
Oh yeah, you'll be fine. So it's basically the same as everyone else's. You're going to have to do things a little bit different than everyone else because you don't have a menu driven, but it'll still work. It'll still give you the same answer. So when I start telling how to do stuff, I'll explain to you just very uniquely how to do your problems. Okay. All right. So that's sine function. Now cosine. Let's do that one next. All right, cosine. All right, cosine of your angle. Well, when you look at the letters A and H, those stand for the walls on when you're using cosine. So cosine of an angle is the adjacent over hypotenuse. The second letter always goes on the top of the fraction, so that's adjacent. And the third letter will always go on the bottom, so now we're going to be dividing by the hypotenuse here. So that's what the little acronym tells me. So adjacent over hypotenuse. And again, on a right triangle, you'd use whatever the bottom wall is, and you divide by the hypotenuse, and that'd be the fraction you'd have set up for whatever that angle is. And again, we're going to use these today to find out actual distances. And then the last one is obviously tangent. Tangent of an angle. So what's the fraction I'm going to put after tangent?
Opposite over adjacent.
Yeah, because O over A, so opposite over adjacent. Opposite wall divided by the adjacent wall. Okay, so these are my three formulas for the main trig functions. And what we're going to look at today is how to use this. Like, if I give you a real-life application problem, could we use these to find an angle or find a length? So that's what we're going to be doing the next couple of days in here. Which I think is kind of fun. Most part, a lot of you learn this in like geometry for the first time, you see it for the first time. Then in Algebra 2, they kind of perfect it a little bit. And then in Pre-Calc, we really hammer it down until you really know it like backwards and forwards. Okay?
What are the two letters after your T up there?
O and A. Sorry, they kind of blend together. Sorry.
Well,
O and A. Toa. Sohcahtoa.
Yeah, that's what
Yeah, sorry. That's a good question. That's what we got to figure out today. Okay, we good though? All right, let's do an actual example here. Does everyone have the formulas though?
Yes.
Okay, so let me explain. I'm going to show you a slide that will hopefully kind of explain what we're going to be doing here, and then I'll show you kind of some funny ways to think about it. Okay? All right. So what we're going to be using these trig functions for is to find the height of an object. So let me give you a slide of what I'm talking about. This will have the definition. So in trigonometry, that's what we're in. It's the study of right triangles. That's really what trigonometry is, the study of right triangles. And it's trying to find the relationship of angles to wall lengths. So the idea is that with a calculator, we can actually find heights of objects using a right triangle. So what this little slide is trying to explain is that you do not need to have direct measures to find it. What I mean by that is like, I don't need to climb this mock Eiffel Tower here. So I don't need to climb the mock Eiffel Tower to figure out how tall it is with a direct form of measurement with like a ruler. I don't need to do that. As long as I have angles and I have one of the walls on a right triangle, I can actually approximate it. Okay, so if you're reading the little paragraph here, it talks about use a sequence of events on this diagram to help me find the Eiffel Tower without climbing. What I mean by climbing is that let's call this Bob down here. Bob could guesstimate the height of the Eiffel Tower if he were to climb it. So like if Bob knew his height, maybe he's 5'10" or 6 foot, somewhere in that range. Bob could literally, calculate his height, and we could put the height of the Eiffel Tower in terms of Bob's. Okay, so far the Eiffel Tower is more than 2 Bobs tall. It's now 3 Bobs tall.
Maybe 6 Bobs.
It's now more than 4 Bobs tall. And this is not drawn to scale by any means. The Eiffel Tower is huge. It's more than 5 Bobs tall.
6 Bobs.
It's now more than 6 Bobs tall. It is almost 6.5 Bobs tall. Maybe almost 7 Bobs. Okay, you could do that. That's silly. You could do that in theory. You could kind of like guesstimate on a picture by, that's why some people they stand right next to the object. You could literally copy paste and figure out how tall the object is if you had the whole thing in frame. But that's silly. That's what they're saying, that we can get around this without doing direct measurements. Okay? So I'm going to get rid of all these Bobs here. These are silly.
I would definitely do that word, so.
Yeah, let's just do that for us.
No, it's silly looking at that. All right, so no, we're not going to put it in terms of Bob's tall. All right, but here's what you can do, okay? You can use the numbers around the actual tower itself to help us out. So here's the idea. You could use what they call an angle of elevation, looking to the top of your object. Now an angle of elevation can be anywhere. You could say any distance from the object and look up to the top of it, okay, to find the angle of elevation. You could use the shadow on the ground to help you out with where to stand. If you're standing right at the edge of the shadow on the ground of the Eiffel Tower or whatever object you're looking at, the angle of elevation will actually look at the sun. Let's put a plot over here and the sun peeking out. Here's the sun. All right. If you're actually looking at a line of sight with a shadow, the line of sight will actually take you directly to where the sun is. That's a line of sight if you're using it like the shadow. But you can stand anywhere. You don't have to use the sun. You could stand where Bob's at and just put, you put a device on the ground to actually measure the angle to the top. Again, most people's cell phones can do that. Okay? So if you had a cell phone, like an iPhone or an Android phone, they can all measure angles. Okay, you can actually put your device on the ground. You have a compass app on every iPhone or every Android device. There is a compass app, and it looks like that. It tells you, which direction is north. But when you slide, it'll give you a level on the ground. So when you tap it, it levels it out, and then you can tilt the phone and tell you the angle you're tilting at. So I can put the phone on the ground, hit the screen, so it levels it out, and then angle it, and it's telling me this is roughly about 40 degrees, roughly. Okay. But again, it's not drawn to scale. But again, you could do that with your phone, and it would tell you the angle. But again, this would have to be pointing at the top of the object, so you have to get kind of on the ground and kind of level it out. You could do it that way. Okay, is that what your question was? Yeah. So you have to get kind of down low and kind of point towards the top, estimate it if you will. But that can give you your angle of elevation. Now, the line of sight again is going to the top of the object. That's where your phone has to tilt. You need your horizontal distance. That would be probably the number you could control, the horizontal level, the distance to your object. That could be either the shadow, or it could be just how many steps away you are from the object. You can actually make footsteps, to the actual object, or actual strides if you're really consistent. And then you'd have to use this angle, and that can help you find the height of the tower. But again, these are like the numbers I could use. Okay, so let me show you this next slide here. That would actually help you find the height. And this is like probably the smartest way to do this. Okay, here's the smartest way to do it. Okay, you actually stand at the spot away from your object where the angle of elevation to the top of the object is exactly 45 degrees, like I showed you earlier. Not just anywhere. Like not, don't go 30 degrees, don't go 15. Find a spot where your cell phone makes a perfect 45. Because if you're standing at the spot that's exactly 45 degrees to the top, and this is supposed to be a right triangle, then this is a 45 degree angle, and now it's isosceles, according to geometry, where this wall and this wall have to be the same size. So the distance you are standing away from the object is exactly the same as the height going to the top. That's probably the smartest way you can figure out the height. But that means you have to be willing to stand really far away from the object to do that if it's really tall. Because it's going to be the same height as the object if you go to the perfect 45. Now to prove my point, I'm going to do the trig function to show you this. So let's say we didn't know this number. Let's say that's what we're trying to find, the height of this object, and I'll call this x. Okay? And so we're going to use my angles. Now what is this wall called?
Opposite.
Opposite wall, okay? So we're going to use the opposite wall. This is now the adjacent wall. It's the wall next to my angle. And so if we're thinking about Sohcahtoa, we could find which trig function to use because based on the labels on my picture. So this one's using opposite and adjacent, so which one should we use? Toa. That's one that uses O and A if I wrote it a little bit easier to see. Okay? So I would be using tangent, right? That's what the T stands for. Because it's using tangent of my angle's 45, is the opposite wall, which is x, over the adjacent wall, which is my 324. Okay, thank you. So, if that's my setup, then how do I find x? What's my rule?
Multiply by 324.
Exactly, because it's called an inverse operation, right? If you want to find x is on the top of your fraction, you do the opposite. If they're dividing by 324, you multiply it over. So that's 324 times the tangent of 45. Now, if you're on a calculator like pretty much everyone has in this room, except for Jared here, you can type it in exactly what you see there, and it gives you your answer immediately. Okay? It'll tell you in terms of meters, because that's what we measured in. But that'll be my number. And it should tell you 324 on your screen. It should be the same number. Okay? Now, Jared, for you, since you don't have the menu driven, you have to type it almost backwards what you see. So you have to type in the 45 first, hit the tangent button, and it'll give you a decimal on your screen, right? And then you take it times 324. It should tell you 1, basically. And then when you type it in, it should tell you 324. So you just have to do it backwards. But it'll give you the same results. Okay, question.
What tall does that mean Bob is in that picture?
Bob is pretty tall. Yeah, the Eiffel Tower, I don't know if it's 324 meters. It sounds about right. It's about, I would say it's about 600, 700 feet tall. So yeah, it makes sense. It's in that ballpark. 900 feet. It's a really tall object. It's one of the tallest objects in the world, other than,
Burj Khalifa.
yeah, the Burj Khalifa.
So does that mean that
Saudi
Bob's like
Arabia.
100 feet tall?
Yeah, he'd be pretty tall. I wouldn't want to do that. So.
Yeah.
All right. Yeah, because that first arc to the bottom is super tall, 100, 200 feet, something like that. All right. Questions on how to use your calculator. Did anyone not receive the 324? Okay. Now I do want to give you an option to like try one by yourself. So instead of using 45s, because that's the easiest way that you can find the height of an object. If you can stand exactly at that 45-degree marker, it's the same. The distance that you walk to the object is the same as the distance going to the top of the object. That's why 45 degrees is kind of the sweet spot. But what if we didn't have 45 degrees? Now we'd have to find the height of the object. So here's what I want. Okay, I'm going to give you an option here. So let's go with. Let's see. No. I have a flag up here somewhere. All right, we're gonna do this one. Okay, so let's say we're trying to find the height of the flagpole. Okay. All right. So here's what I want, and this will be kind of the options up to you. We're gonna say the angle of elevation to the top of your flagpole is 30 degrees. I don't want to do the 45-degree thing, so I'm gonna tell you right now. Wherever you're standing away, it has to be 30 degrees. So I'm going to just predict that for you right now. You guys get to pick this number.
741.
So you can pick whatever number you want. Okay? I'm going to walk around the room. What I'd like you to try to do is, and again, you get to pick this number. So this is the number you get to make up on your own. I want you to find the height of this flagpole doing the same math we just did. Same math, but you get to pick the distance you are away from that flagpole. My last class, people were picking crazy numbers. That's fine. You can pick whatever number you want. Just make sure you label it, and you have to use 30 degrees. And I want to figure out how tall your flagpole is. Okay? I want to walk around the room. I'm going to take a little camera. I want to see written on paper, like the drawing with your numbers in it. And I want to see that you can type it in front of me to give me what the number is that you just found. Okay? Just the same math that we just did. Got it? Okay, and I'm going to take the camera around and I'm going to self-record you. Okay? And you don't even have to talk. I just want to see it. Okay, so Morgan, what was the distance you picked?
938.
It's 938. What's the label on it?
What?
Feet, meters, yards, what do you want to do?
I don't know. We're just going with it. We're doing feet.
Feet, okay. You type it in, so what's your number then?
541.5.
Okay, good, because I agree with that. Because what was your original formula? You had-
938 tangent.
Okay, good.
30.
Yep, good. Okay, Jared, what was your number?
352.
Okay, nice. And then your formula. Okay. And what was your, all right, your labels and feet?
Feet.
And then how do you type that in for you?
I have to go backwards.
Nice. Good. And you got what was that?
203.
Yeah, that makes sense. That was kind of a bigger number. Okay, good. All right.
I'm lost, Lord.
All right, so what was the number you picked?
700.
700, okay. So now let's write down a formula. So you have it labeled. I agree with your opposite and adjacent you have labeled. So which one of the three trig functions would you pick? Which one would you pick? Which one, if you think about the formulas themselves, which one would you pick that would use opposite and adjacent? If you think about Sohcahtoa. Toe, so you're going to pick tangent. So tangent of your angle, and your angle is what?
30.
30, okay. Is the opposite over adjacent. So what's your opposite wall?
X.
X over what's your adjacent?
700.
700. Now, what's the math you're going to have to type in?
700.
Good?
Or tangent 30 times 700.
Good. And what number did you get?
404.
404. And what's the label on that?
Feet.
Feet. You want to do feet? Okay. All right. Go to what do you got?
I got 55 feet, and then I had to do tangent 30 equals x divided by 55. You gotta multiply 55 over to
And can you type that in for me, just so I can see it?
55, tangent, no.
When you do see it, like, right. Turn back. Right.
31. And that's the number you got?
Yep.
Down your shirt.
Okay, Kaylee, what do you got?
It's 620.
Okay.
And then I did tan, or toa.
All right, you want to type that in the calculator for me so I can see how you got that?
1994.
Sorry, Mark.
I'll just hold it, you talk. You can't do two things at once. I'm helping.
All right, and so what's your label on that?
Feet.
Feet. Okay, good. All right, let's go over here. Good. I like it,
Hey,
Mark. Thank you.
Sydney.
All right, Sid.
How's it going?
All right. So, Sid, you picked 123. So,
Yep.
how do you type it in your calculator then?
I do 123 times tan, 30
30. Perfect. And then what's your label on it?
feet.
What are the
All right, good. Mark.
Mara.
I picked 602.
Okay, good.
So I put in 602 times tan of 30 and I got 347.6
Okay.
feet.
All right. And can you type it in the calculator for me just so we can see it?
I am upside down, aren't I?
I had more until I spent like 20 pennies buying something.
So you can stop. Tyler.
Hello.
All right. Tyler, show us what you got. What was the number you picked?
So I picked 724 feet, as you heard earlier.
Yeah.
And I did tangent of 30 times 724.
Okay.
and I
Type it
got-
in your calculator so I can see it.
Oh. It's 418.0015949
And what's the label on it?
feet.
Feet. Good.
Going to Ray.
Okay, Ray, what do you got?
I did 670.
670. Okay.
So I did 670 times tangent of 30, and I got 387 feet.
Okay. And can you type it in?
670. That's rounded up.
Nice. And the label on that?
Feet.
That's good. All right. Austin, what do you got?
28.9 meters.
Okay, so what was the number you picked up?
50.
50 meters? All right, and then can you type it in your calculator so we can see it? Oh, it looks like you already have it. Perfect, so just show that on the screen. Perfect. All right, thank you.
Cherise.
Alright.
Precious, what do you got?
Alright, I picked 10
Okay.
and then I typed in 10 and then tan and then 30 and
Good.
then I hit enter. And then I rounded up to 5.8
Good.
feet.
Sitter, what do you got?
Jaden.
I picked 420, so I typed in 420 times tan 30
At my house, full.
242.
What a great one to end on. Hyper stop.
All right, the red bar.
This one?
Okay, so the last example today is, okay, the last example here is, and this is just kind of a rough example. Again, I just want to see kind of what some people are going to get on this one. Let me get rid of the pictures here. All right. All right. Last example is, let's say you're on a top of a mountain, right? You're going skiing. Okay. So here's my mountain, and let's say we know the height of the mountain. Let's say the mountain itself, because you know your elevation. Let's say it's 6,200 feet.
It's a lot of
Okay. Big mountain, I think in Colorado, some of those mountains can get up to 10,000, somewhere in that range. So if you're at 6,000 feet, and let's say that there's a guide wire coming down for the actual the lifts for the skiers, right? I want to know how long the cable is. Okay, and let's say the angle that it's making with the ground. Let's say that is 20 degrees. Okay. The idea is that we can set up a right triangle. Okay, so you can set up a right triangle there, and we can find this height. Now, we do have to label the picture before we start, because I don't know which one of the three main functions to pick. So let's label the picture. So we have my angle, so this is my theta, right? Now, what is that side called? Opposite. That's opposite, okay, that's O. And what is this wire called? Hypotenuse. It's the biggest side. It's the side that doesn't touch the right angle. It's one of the longest side of that triangle. So now, if I'm thinking about it, if that's the longest side, what should that number be bigger than?
All the
6,000. It should be bigger than all the rest of the walls, okay? So we need to find that number. So now, if we're thinking about Sohcahtoa, we have to figure out which one of these three to pick. It doesn't have to be tangent every time. That was just the first example I showed you. So we're using opposite and hypotenuse, so which one uses that? Yeah, that one. That's how I know which one to pick. I label the picture, and then the labels on the picture will tell me which one of the three main ones I should pick. Now, on this one, sine. It's sine of your angle, so sine of 20. is the opposite wall, which is my 6,200 feet, over the hypotenuse, which is the number I'm trying to find. Now, this is the goofy part. The x is not on the top anymore. Okay, we're not just going to multiply the 6,200 across. What do we have to do?
Multiply by x.
Yeah, we have to multiply the x across. The x is on the bottom. So we have to move the x. In fact, here's the shortcut. If the x is on the bottom, just switch these two. Just switch them. So the x will come over here. That sine of 20 will go on the bottom. And that's what I want to see typed in. Okay, I want to see that. I'm going to walk around the room. I'm going to check that. And I'm not going to take the camera. I just want to see what you guys come up with. Can you type it in? All right, so now, Jared, for you, you have to find the sine of 20 first and write the decimal there, okay? Because you won't be able to just type in and enter. You have to find the sine of 20 first, a 20 sign. Write down that decimal in your, like, as many decimal places as you can. Then take 6,200, divide by that decimal. So you kind of have to do a two-stepper, okay? All right, I just want to walk around the room, and I want to know what is the label. What is that?
And my label is going to be
Feet. Good. Morgan, what do you got?
So I'm gonna do 6,200 and the percent, and then 20 close to equal whatever comes up.
Wait, you don't have
You
an
get-
answer button underneath that?
John, what'd you get?
Who? 18,000.
18,000 feet.
18,120.
Alright. Type it in, you wanna get that? Set that little thingy. Type it in there, Mark. Perfect. What's the label? Okay. Good, good. Okay. Good. I want to see type it in.
We all have enough staff.
So, because when we label the letter, this is the opposite wall, the wall is dash.
Yeah, you going?
Yeah, so like, when you're labeling a picture, you always want to label one wall that you have, and the wall you want to position you play. And then it should tell you how much. We'll practice more.
Center, power forward,
Now
shield.
close, now point in.
Alright, good. Alright, you type it in? Excellent. Alright, good. Alright. Now, hey,
Post to center.
okay. John, you were the first one. What was the number you came up with? Everyone else came up with it? Except for Morgan. Alright.
Well, I didn't point me out.
I always have. It was 18,000.
127.
27.58.
587.
Alright. And that's in, what's the label? Feet. Alright. Now, hey. What that means is that that's the length of the cable. That's my hypotenuse wall. Now, in terms of like mileage, you know, if I divided that by 5,280 feet, that's how many feet are in a mile. That's 3-4 miles, somewhere of that, of cable. That makes sense. Because when you divide this, to convert it back to miles, you have to divide by how many feet are in a mile. So 5,280. 3.4. So about 3 to 4 miles. Now that's just one direction. It's when you do those cabling systems, they have two cables forward and back, so it rotates. It just turns. But yeah, so kind of long. I mean, that's in some places that's nothing, because some of those mountains are way taller. I think some of you guys are saying like some of those mountains can get above 10,000 in certain places in Colorado.
We should do a revolution problem and see how fast it goes so far.
Yeah, it's true. We could do something like that. That would literally be a problem we could do. Okay, question.
Pre-calc should take a field trip to the Rocky Mountains.
If we could go skiing, oh, that'd be the dream. So,
That'd be the dream.
that'd be the dream. All right. Hey, are we good?
Yep.
Okay, we're done for the day.
Sweet. Skidoo Bob.